This video covers section 5.5 part 2. So we're only going to cover the last two slides of the section. And what we have here is a trigonometric equation. And we're going to find the solutions that are in between this interval from 0, including 0 radians, to 2 pi, but not including 2 pi. So if you notice here, it says use an identity to solve the equation. So the identity that we're going to use is the one that, and right now I have it written on the dry erase board, so I'm going to write it here so you can all see it. So for sine of one angle, in this case alpha, times the cosine of another angle, in this case beta, the formula for that will be 1/2 times the sine of the addition of the two angles plus the sine of the difference of the two angles. And so that is the formula I'm going to use, but what's happening here is that fortunately the two angles happen to be the same thing, right? X and X. So when we apply the, when we use the identity, it will look this way. 1/2 times sine of the sum of the two angles plus the sine of the difference of the two angles. And so that we're saying is equal to 1/2. The 1/2 I'm getting it from here. Okay? All right, so what I'm going to do next is I'm going to combine what's inside the parentheses. So in this case, we will get 2x. And here, we're going to have sine of, what will we get? X minus x. They're opposite, so the answer is 0, right? So sine of 0. Okay, do you guys remember what is the sine of 0? Look at your graphs. If you look at the y-axis, it starts right at the origin, right? So the sine of 0 is 0. So from here, we could say it's going to be a 0. So what that means is that we'll have 1/2 of the sine of 2x is equal to 1/2. Now, one thing we can do here is we could multiply the whole thing by 2. And by doing that, what is 2 times 1/2, guys? A 1. And then what is 2 times this other 1/2? A 1, right? So if we do that, it's going to just help us get rid of the fraction of the 1/2. And so we will have sine of 2x is equal to 1, right? Remember, I'm getting the 1 from multiplying 2 times 1/2 and then 2 times 1/2 here. Yes. Well, because that one, we are going to have to leave it alone because that's the angle. So remember, when we're talking about trigonometric expressions, the angle and the I guess the abbreviation of the trigonometric ratio, they go together always. So it's kind of like when you have things inside a radical, like x plus 1, you don't really go and distribute the 2 inside. Okay, so in this case, we do the same thing with the angle. We don't distribute it. We only distribute it to the coefficients. So the coefficient here was 1/2, and then here we distribute it to the constant term. Now from here, we know that to get rid of sine or undo sine, we need sine inverse, correct? So we get the sine inverse of 1. And so think about that unit circle. Where is the y coordinate equal to positive 1? Here, right? Isn't it true? 0, 1. So that means that the sine of one angle is 1. What angle is here, from here to here? 90 in radians? Pi over 2. Pi over 2. So that will be pi over 2. And that is the only solution because if we picked another one, well, actually, let's add that notion of the infinite amount of solutions, the 2n pi. But now remember that we're trying to solve for x, so in this case we're going to have to divide by 2, right? So it will be pi over 2 divided by 2, and then it's going to be 2n pi divided by 2. So what that is going to give me is pi over 4. We use the sandwich rule here, so pi and then over 4 plus n pi. So in fact, doing this part right here, it will be necessary, okay? Because if we don't, then we're only going to get one solution, and then my math lab is going to count it wrong because you don't have all of them. So let's find what those solutions will be. So if n is equal to 0, this n right here, x will be just equal to pi over 4, correct? But if n is equal to 1, it's like our second solution will be pi over 4 plus 1 times pi. So what would that give me, guys? So pi is equivalent to 4 pi over 4. So 4 pi over 4 plus pi over 4 is equal to what? 5 pi over 4. Very good. And I don't know. Could we get another one? So far we have 1 and 2. Let's see. If n is equal to 2, that will be like we're adding 2 pi, right? So that's kind of like a red light. Like if you add 2 pi, you're obviously going to go past 2 pi. So we don't need to do that. So we stop there. And our only two solutions that are in between this interval will be the pi over 4 and the 5 pi over 4. Okay? Any question on that one? All right. So remember, for this one, we had to use an identity. Okay? Now, let's move on to example 10. And we're also going to have to use an identity for that one. Thank you. Let's move on to example 10. So we're going to use an identity, but before we do that, we're going to use a little trick here, okay? So that trick is going to be that we square the left side, but if we square the left side, we must square what else? The right side. So you could always do that with equations. So if we square this, please don't just say sine square x plus cosine square x, okay? We're still missing a term in the middle. And that term in the middle is going to be the product of sine x times cosine x, and then you double it. So 2 sine x cosine x. Kind of like if you were multiplying a minus b squared, it will be a squared minus 2ab plus b squared. Yeah? Are we okay with that part? So you're multiplying a binomial times itself. We did the following. Sine x minus cosine x times sine x minus cosine x. Okay, that's what we did, and that's how I obtained this one. If you don't know the shortcut, then you are more than welcome to expand it one by one, okay? Especially on the test if you're not sure. One very common error that I see on exams is that you guys forget that there's another term in the middle, okay? So please be aware of those. Why are you so smiley, Beth? Okay, Dima, don't distract.
No,
or I'm going to have to ask you to leave. Okay, so we have that, and then what happens when we square the right side? What number do we get? Just 1. Now, one thing that is very convenient here is that if we put the sine square with the cosine square, since they are the same angle, by the Pythagorean identity, they're equal to what? To 1. So we can just write that. So 1 minus 2 sine x cosine x is equal to 1. Now, if we subtract 1, or if we were to take this positive 1 across, right, it will just be 1 minus 1. so we all know that is 0, right? Now, what is the -2 doing to sine x cosine x? Multiplying. So we all know we need to divide, but this is pretty convenient because we're just dividing 0. So 0 divided by any number, it's always going to be 0. That's it. So now at this point, since we have one side equaling 0, we could split the two factors, and I call them factors because they're multiplying each other, right? They're not adding or subtracting, they're multiplying each other. So we could use the zero factor property and say cosine x equals 0. Well, let me write sine first, because it's on the left. Sine of x is equal to 0, or cosine x is equal to 0. Now from here, let's think about that unit circle. So we have 1, 0, 0, 1, -1, 0, 0, -1. So let's think about sine. Where's the sine equal to 0?
90 degrees and
Well, sine is the y coordinate.
oh then
At 0
degrees.
Okay, so x will be the sine inverse of 0. So that will be 0. Oh, who's knocking? At 0 degrees or 0 radians. And then where else is the sine equal to 0? Right here, right? At pi. Now moving on to the right side, so cosine x, where's the cosine equal to 0? And you know what, guys? It's something that I've never mentioned, and I know it's on your book, and you've probably seen it on your homework. What's another way to say sine inverse? Arc sine.
What?
Yes, I should have taught you that a long time ago. So how do you guys think we could say cosine inverse? Arc cosine. And then how can you say tangent inverse? Arc tangent, yes. Just in case, okay? Just in case you see them. They have the exact same meaning. So where is the cosine equal to 0?
Over 2.
At 90, so in radians, 90 is pi over 2. Okay, and where else?
3 pi over 2.
3 pi over 2. Okay, great. So we have 4 solutions, right? And if you notice, the 2 pi, we cannot, even though the sine of 2 pi is also 0, we don't include that 2 pi because it's not in between the interval where we want our solutions to be at. We want them to be smaller than 2 pi, but not equal to 2 pi. So let's move on to the next slide. So our last 2 problems. Yay. So all of you got a calculator, right? Yes? Okay. So this one, pretty easy. It will just be x is equal to the tangent inverse of 12.8044. And here, x will be the cosine inverse of -0.4317. So I would like for you guys to find that on your calculator. Some of you might give the answer in degrees, other in radians. I think here you have to just be very careful when you answer questions on my MATLAB and make sure that you get that you answer how they want you to answer, whether it's radians or degrees or exact answer, approximation, blah blah blah. Arc sine will be the same, okay? Some calculators might have like that one, and maybe you go to the menu and find it there. But it's the exact same thing. But they have the same meaning, so go to the or something better. But when you hear that, you know it's the same thing. Okay, so Samantha, what do you get for part A?
85.
85. And let's round to 4 decimal places. Do we have more decimals?
Yeah.
Okay, go ahead.
5.3.
So point.
5.3.
Uh-huh.
4.
4. Very good. And I'm assuming that's going to be degrees. Did anyone get anything else? Because that would be the answer in radians. So think about it. If it's 85 degrees, that should be somewhere that is less than pi over 2, right? In first quadrant. Okay. Jesus, what do you get for part B?
115.575.
115 point. Say again.
575.
Bless you.
Degrees. And it kind of makes sense to me because if it's more than 90 degrees, that means that it's somewhere in the second quadrant. And yes, the cosine in second quadrant is negative, right? Okay, very last problem of the day. So, solve the equation to correct 4 decimal places. So what we're going to do here is we're going to factor, okay? And then we're going to have to use the calculator. So actually, let me see. If we have something like this, w squared minus w minus 1 equals 0. Could we factor that? Let's think. Will that give me this polynomial? No. Because, and I mean, I was trying to factor it. The sign is negative. That means these two signs will have one of each, right? The only factors of 1 are 1 and 1. But if we multiply them, we will end up with a difference of squares. We will end up with that. So that means this is not the correct factorization. So, meaning we have to use other methods, maybe the quadratic formula, okay? So what we're going to do is use the same coefficients that we have here. So for example, coefficient here is a 1, here is a negative 1, and here the constant term is a negative 1. So I'm going to say that A is equal to 1, B is equal to negative 1, and C is equal to negative 1. So now for the quadratic formula, we will have the negative b plus minus the square root of b squared minus 4ac, everything divided by 2a. And of course, we need to substitute, right? So for negative b, negative is already, I'm sorry, b is negative already. So we will have that negative times negative plus minus square root, and then b is negative 1, we have to square it. Then we have a minus 4 times a, which is 1, times c, which is negative 1, times 2a. A is 1. Now, for this exam, you guys will be allowed to use a calculator. So all I'm going to ask from you is that you at least give me the substitution, okay? And then you can just enter that on the calculator. I'll be fine with that. So here will be plus 1, because we have negative times a negative, then plus minus. Inside the radical, we'll have 1 squared, which is 1. And then here we'll have negative 4 times 1 times negative 1, so that will be negative times negative is what? Positive. So positive 4. All of that divided by 2. Now, don't forget that we have 2 solutions, a plus and a minus. Okay, I just don't want to call it x, because we're not actually getting the solutions for x. We're getting the solutions for what, guys? For sine of x. So what I'm going to say is that sine of x could be 1 plus the square root of 5 over 2, or sine x could be 1 minus the square root of 5 over 2. And of course, those two solutions are coming from here, all right? So for x, we will have to take the sine inverse of this whole expression. And you can enter it like this on the calculator. And of course, you're going to get an approximation. So same thing here. Make sure you use parentheses to enter the whole irrational expression on the calculator. And we look at the instructions, we could see we need 4 decimal places. So please go ahead and complete that, and then I'm going to ask you randomly. So all of you. Also, if you feel like you got lost in one of the steps, just let me know at this time so I can explain it. And again, be careful when you're doing your homework on my math lab. Do you need degrees? Do you need radians? What do you need? Also, I'm aware that I have not assigned the homework, so I am going to assign it. And then I'll give you guys extra time. What do we just assign? 5-4 and 5-5, right?
Yeah.
Yes. So for those two. So, do you guys think we should move the test to Wednesday and then have a section on Monday?
Yeah.
Like we did last time?
Yeah.
I bet it's because you guys procrastinate too much.
But at the same time, you're gonna study for your tests while you were.
Oh, don't bring that up. That doesn't count.
Oh, that I didn't study for it?
No.
Yeah, but I already have a bachelor's and a master's. I mean, I'm just taking this class for fun.
Sure.
Extra stress.
To be honest, yeah, it's for fun. I enjoy it.
Extra stress for fun?
I feel so smart.
Like stress.
But I gotta.
I don't
Did
feel
anything?
I just suffer when I get bad grades, but I don't stress. Like Alpha told you, like, just let me do it. No, not doing better than me. We're kind of like,
Same.
because the second exam I got a 92.5 and she got like an 80. And then the first exam, I know. Okay, do we have the answers?
How was the recording?
Ruben?
I got one.
That is fine?
Yeah.
How could you? I don't understand.
You already know.
Okay, so let's do something. Without entering sine inverse, can you guys just enter this operation right there?
Square root of 5 plus 1 over 2.
And then do the control enter to get an approximation.
1.61.
Oh, so that's why, right? Because the sine cannot be bigger than what? Than 1. So that's why we got here undefined. All right, how about the other side? Did we get something interesting there?
Negative 38.1727.
Point.
1727.
Okay, now why is it negative? That's a great question. So let's think about back in the day when we went over the sine inverse function. Do you guys remember how we restricted the function and it went from negative pi over 2? That was like section, like chapter 4. Yeah, long time ago. So what this calculator is telling you is an angle that is negative and it's 38 degrees. So it will be somewhere maybe here, right? So could we find another angle that is positive? Because I believe that's the question, right? We want our answer to be like that. Positive, greater than 0, and we want it to be less than 2 pi. So think about an angle that you can take from here to here. How can you find that?
At 360.
Okay, at 360. So if you consider that x1, let's say that x2 is going to be 360 degrees minus 38.1727. So that will give us what, guys?
321.827.
21?
0.827.
Oh. So that's how you will have to give your answer, okay? Because even though the calculator is giving you a negative answer, that's not what my math lab is going to want from you. All right, so we are done. This is the end of section 5.5. 2.